We will be back around 9:15 to get anybody that's running late. We will start the party here. All right, gentlemen, welcome. This is the top of week 7. As usual, if you have questions, feel free to unmute yourself to get my attention, and we can talk about it. Let's see. So, you know how this goes. Like, today we're gonna be working on the last section for chapter 1. I think it's 1.6 combining functions and composite functions. So what that means is that exam 2 will become available this upcoming Sunday, right? It'll be available from this Sunday to the following Sunday. This Sunday, it'll become available at 11 a.m. and then it'll be due 7 days later at 11:59 p.m. on Sunday night going into Monday morning. I know midterm grades are due around that time, so we should be able to get this exam on midterm 2. I try to wait until after this exam is due before I calculate midterm grades. And let me do this disclaimer about midterm grades. So if you're stressing or worrying, unless the stressing and worrying is serving you and like making your life better, you got to release that, right? If something rubs you in that way where you feel anxious, then all that means is that, okay, wait a minute, this thing needs attention, right? So if you're nervous or worried or anxious about your grade, there are 2 things. One, the midterm grade is just a snapshot of where you are in that moment in time. And if it's making you feel anxious, then that means that it needs some attention. All you got to do is devise a plan and position yourself for success. You got to ask for help. You have a slew of help, right? I'm here, you got your classmates, you got tutors that you've already paid for. Pearson, hopefully you can see why I set it up the way it is, because a lot of it is like, you learn on your own. Each question has an explanation in the view and example and all that. They give you at least some backstory to every question, nearly every question on the homework. So your supporter, you have to speak up, a closed mouth don't get fed, right? But yeah, so the midterm grade is just a snapshot of where you are at that moment in time. It has no bearing on your final grade, right? And so like if you're not where you want to be, then you have to do something different. If you are where you want to be, like one level is getting there. The next level is maintaining that status, right? Getting there is one level, is one thing. The next thing is now how long can you maintain that status, right? Okay, so hopefully everybody's doing what they need to do and, they're able to keep forging ahead. Okay. So I can't think of anything else but I want to say this upcoming Monday and Tuesday is fall break. I saw something, I think that's the case. Yeah, so we might not meet on this upcoming Monday because I think it said October 3rd. Let me see if I can. Anyway. If I find that, I'll probably send an announcement or something just to remind everybody. Okay. So again, if you have questions, feel free to unmute yourself. Otherwise, we're just going to go ahead and kind of get started with the presentation. So this is the last section in chapter 1. It's going to be over before you know it. You're going to blink your eye and we're going to be done. We're already halfway through, right? I don't know if it feels like we just got started to you or not, but it goes very quickly. Very, there's that word again. It goes quickly, right? Because quickly already means very fast, all right? So today we're looking at section 1.6, combining functions and composite functions. And we have a few objectives. We like to define basic operations on functions. We like to form composite functions, find the domain of composite functions, decompose a function, and apply composition to practical problems, okay? So we have the sum, difference, product, and quotient of functions. Let f and g be 2 functions, then the sum f plus g, okay, yeah, we're fine. So the sum f plus g, the difference f minus g, the product f times g, and the quotient f divided by g are functions whose domain consists of those values of x that are common to the domains of f and g, except for f divided by g, where all values of x where the denominator is 0 must be excluded. Right? Because again, we can't divide by 0. So any x that makes a denominator 0, we have to throw out. These functions are defined as follows. So the sum of 2 functions. So this is function notation, right? this is f plus g of x. What this means is f of x plus g of x, right? A common error that students do, they treat this like distributing, right? That's not what's going on here, right? So this notation, when it looks like this just means the function f plus the function g. Sometimes I've seen where students would take this and they try to distribute an x, and then it just throws everything off. It just goes downhill from there. All right. So again, this just means f plus g, right? This just means f minus g. This just means f of x times g of x. And this just means f of x divided by g of x. Again, we had to throw out any x that makes the denominator 0. Okay. Okay. So we have f of x is this guy here, and g of x is this. So find each of the following: f minus g of 4, so on and so on and so on. Okay. So what we could do here, so basically what this is saying, when you see f minus g of 4, what this means is f of 4, I guess I need to write it out. I was trying not to write it out, but I think I'm just being lazy. So let me take some time to write it up. Okay. So again, we have that f of x is x squared minus 6x plus 8, and our g of x is x minus 2. Okay. So then for part A, they asked us to find f minus g of 4. We'll just go ahead and write all of them. Part B, f divided by g of 3. Let's see, f plus g of x, okay. F minus g, let me make that look more like a minus, of x, e, f times g of x, come on. F times g of x, and then f divided by g of x. Okay. So then now for part A, so f minus g of 4, all this means is, f of 4 minus g of 4. Right? So then we can evaluate f when x is 4, evaluate g when x is 4, and then subtract those two answers, right? So let's do f of 4 first. So usually when I'm evaluating functions, first thing I like to do is replace each x with a blank set of parentheses. So we got x squared minus 6x plus 8. Also, as a reminder, hopefully everybody has been making their way through the lab component, right? So you've connected with Dr. Lamar and you've been following her instructions. I think that's included. Basically, I just take whatever grade she gives me and I scale it so that it's 10% of your overall grade, all right? I need to update that grade book. I got to figure that part out. I still haven't figured that out, but okay. And so here we're replacing each. So first thing I did was replace each x with a blank set of parentheses. And then I'm plugging in 4, right? The parentheses just help us to keep track of our signs if we ever substitute like negatives. So then 16 minus 24 plus 8, was that 0? Okay. Okay. Oh, wait. No, that's only f of 4, right? Let's at least highlight it. Okay. So then we need to also go ahead and find g of 4. So then G of 4 is x minus 2. So we're going to say x minus 2. And again, we're plugging in 4. So then that one's 2. All right. So then when we do f minus g of 4, that's going to be 0 minus 2, which should be negative 2. Okay. All right, let's get a copy of B. Let's give ourselves some more space. Go ahead and put it here. So this is f divided by g, right? What this means f of 3 divided by g of 3, right? We're not distributing there, right? Let me finish this one. So let's do f of 3. So then f of 3, we got x squared minus 6x plus 8, okay? We're plugging in our 3 into the parentheses. It's going to be 9 minus 18 plus 8. Looks like that's a negative 1. Copy and paste. Okay. Oh, I always do this. I don't know why I keep doing that. Just moving way too fast. So we need to highlight that because that's just f of 3. All right. We still need to do g of 3. So x minus 2, x is 3 in this case, so that's going to be a 1. So then when we do f divided by g of 3, that's going to be, let me highlight, f divided by g, so that's going to be negative 1 divided by 1, which is ultimately negative 1. Okay. Again, if anything is not clear, you just have to unmute yourself to get my attention. Let me check to see if we got any stragglers. Comers, so we go like this. We got a few, so let's do like this. And I'll check the chat. I see there's some activity there. This one. Fine. Okay. Okay. Cool. Wait a minute. All right. And then let me go ahead and let me check the chat real quick. Let me see. Okay, so if you're like if you haven't been able to gain access, like full access to Pearson, that's part of the reason why I only did like a 10% late penalty. The main thing is you just need to keep practicing, and then once you are able to gain full access, you can always go back and make up missed assignments or late assignments, right? So obviously it's going to affect your midterm grade, but as long as you're able to gain access before the end of the semester. Now, if you're trying to, like, if you're working back, like if you're gaining access kind of late, then at that stage, again, hopefully all the while you've been practicing, and then you really want to prioritize your exams, right? Because I think the exams count for nearly 80% of your overall grade. So once you gain full access, you can always go back and like you get unlimited attempts, and there's only a 10% late penalty, right? So it's you can still honestly get an A. I mean, that doesn't happen because most people don't get a perfect score. You would have to get a perfect score in order to get an A- if you did it late on everything. But there's still a high chance you can get like a high B. You know what I mean? So it's I don't want to be like, don't stress, because worrying is just praying for things that you don't want to happen. It doesn't really serve you, unless it is, and that's different. But again, that's what I mean by making a plan. Again, that's the reason why I do unlimited attempts. I push the late penalty back as far as I can, basically at the end of the week of finals, right? So that it's usually the first week of December, the first full week of December of finals, and then that Friday, I make everything due that Friday on the week of finals, because then we have to crunch grades and calculate grades and submit final grades and things at that point. So that's the latest that I can push everything back. So you essentially have until then. F plus G of X, okay. So hopefully that should kind of answer questions. F plus G of X, copy. Because again, that's not your fault. And I've had students that, if that's what they had to do, that they did it and they were fine. They kept moving, and that's not it. That's not like there's this philosophy that goes, why share in the blame when we can share in the glory? Like instead of putting so much energy into trying to place blaming society or stuff like this, why share in the blame when we can share in the glory? Let's just try to focus on the win-win. Let's be solution oriented. So that way we can share in the glory. Let's figure out a way to take care of as many people as possible, and then, again, the concept is, why share in the blame when we can share in the glory? I think I saw it in a movie, to be honest, but yeah, so that's a huge motivation for why I set things up and why I do a lot of things the way that I do them. Okay, F plus G of X. Okay, so this one's kind of straightforward. This one just means F of X plus G of X. I was going back and forth because I guess I can just copy and paste, or I can just move this, to be honest. Let's just drag it down. Okay. So what this means, basically, we're just going to say this plus this. All right, we don't need parentheses here because nothing is being distributed or anything of that matter. That's fine. And then basically we combine like terms, right? Like terms, they have the same variable with the same exponent. There's only one x squared, so that's by itself. Negative 6x plus x is going to be a negative 5x. 8 minus 2 is going to be a positive 6. Okay. I feel like this is okay. So combining functions it's fairly intuitive. There's another one that's coming up. Let me go a little bit faster. If we were to get, I mean, I guess we could have done this, if we were in class, I would assign this as classwork. I don't think anything interesting happens with the remainder of these. So I'm just going to piggyback on my prepare notes. So we'll start here. But I feel like it's fairly straightforward. So for part A, we got -2. We got -1 for part B. And then, okay, so on and so on, right? So you see the -2 here. You see the -1, and I think they did all the same stuff that we did. For part C, F plus G of X, notice is here. This is where we stopped here. We made it all the way to this, and I think we got the same thing. Part D was F minus G of X, so that just means F of X minus G of X, right? So basically it's the same as part C, just change this plus to a minus. Now, one thing that is interesting here, with this being a minus, you do have to distribute that negative. It's like negative, it's multiplication over addition. So then that becomes a minus X and a plus 2. That turns that into a -7 and a positive 10. Okay. So I don't know how many of you are like new to Atlanta, but Atlanta's a lot of fun. I'm not gonna lie. I mean, I'm just saying that just because it's like like usually in the summers and around this time of year, I mean, honestly, it's all year round, but especially in the summer, there are like a lot of festivals downtown and like Piedmont Park and, just all over the city. It's just like events, and, there are paid events and there are a lot of free events too, concerts and all sorts of things, just, I just encourage you to like, explore the city. It's a lot of fun. A lot of restaurants. Atlanta's a food city, right? So nearly any cuisine that you're looking for, you can find it here. Honestly, that's low key one of my goals is to list out like as many restaurants as I can, and then like over time try to like taste at least every dish at least once. Like I think that would be fun. Just okay. Today we'll do this to this, from the list, and just check it off one by one, just for the sake of doing it. I think it would be fun. Keeping going forward. So E was F times G, right? So here we have to distribute, right? Basically, this X needs to be multiplied by each term here. And then we need to do the same thing with the 2. All right, it's like foiling. It's just that each term from the first expression has to be multiplied by each term in the second. All right, you expand it all the way out, combine like terms. And then for F divided by G, looks like this can be factored, right? Maybe we should have done it, but we'll work some others. I felt like this one wasn't too terribly bad. I guess I should have kept going, but Now we do get some like terms to cancel. This X minus 2 cancels this guy. This leaves us with X minus 4, and we do have to acknowledge that X can't be 2 because that makes 0 in the denominator from the original, right? Even though it cancels out, X still can't be 2 because it creates a 0 in the denominator in the beginning. Okay. All right, let's see what else we got. So then we have this concept of composition of functions. So if f and g are 2 functions, the composition of function f with the function g, is written as f composed g, this guy right here, all right? And is defined by the equation f composed g of x means f of g of x, all right? Basically, it means the second function inside the first function. This symbol is called composition. Oftentimes when students see this, they'll confuse it for multiplication. This is not multiplication, all right? The symbol means the second function inside the first function. So it's like one function inside another. Where the domain of f composed g consists of those values in the domain of g for which g is in the domain of f. Okay, so when we go to find the domain of this function, there's a 3-step process that I do. I'll just say it for now. So finding the domain of a composite function, first I find the domain of the inside function, then I find the domain of the simplified function, and then I take their intersection, all right? So that's just a precursor. Let me say it one more time. To find the domain of the composition, first we're gonna find the domain of the inside function, then we're gonna find the domain of the simplified function, then we're gonna take their intersection, okay? So hopefully we get a chance to see that in action. And this is kind of like an overview of that, right? Showing you where the domain of the composition of this function comes from. So if you think about the domain of G, that's essentially what this is about. But again, I feel like it'd be more simple if we just work an example and you see it in action a few times. Do they want us to find the domain here? No, because we're just evaluating, right? So first we're just evaluating f composed G of 1, right? Okay. Yes, I will need some space. So let me give myself some space. Let me give myself a little bit more space. I don't need that much, but okay. So we have that f of x is x cubed. We have that g of x is x plus 1. So then for part A, we have f composed G of 1. Part B, G composed F of 1. And then for part C, F composed F of -1. Okay. Okay. So then for part A, f compose G of 1. This means f of, let's do G of x, let's do that in green. F of G of x. Second function inside the first function, all right? Okay, if we keep going, so then this means f of, now what's our G of x? G of x is x plus 1. Okay. So then basically what we're doing is we're writing f of x like normal. We're replacing each x with a blank set of parentheses, and then the green thing goes into each blank parentheses. Okay. So f of x is x cubed, and we're replacing each x with x plus 1. Okay. So then this means x plus 1 times x plus 1 times x plus 1. Okay. So this means, yeah. All right. If you FOIL, first outer inner last, and then if I distribute, that's going to be x cubed plus x squared plus 2x squared plus 2x plus x plus 1. All right, then we combine like terms. 3x squared plus 3x plus 1. Can I paste? Probably not. Oh, awesome. Okay. So that's what we got for part A. Let me, okay, so for part B, we have G of f of 1. G compose f of 1. And again, what this means is the second function inside the first function. So we're saying G of, for f, I usually like to do, that's about the closest I can think of what fuchsia looks like. F of 1, right? Okay. Oh, okay, I gotta go back. Actually, what this should have been, let me just, we should have did this in a little bit differently. And we're still not done because we forgot. I think that one was x was 1 for the previous. So really, we should have done it a little bit differently, but like I said, for some reason, I don't know, I'm totally distracted. All right, keep going. 1 plus 3 plus 3 plus 1, 8. So I forgot that we were evaluating. I don't know, for some reason I wrote it wrong. I would have done it a little bit differently. Let me show you how I can do it. Let me do it in this one the way I would have done the first one. So if we're doing G of f of 1, let's first do f of 1. All right, let's first do f of 1. F of 1, f is x cubed. So then that's going to be 1 cubed. That result is 1. Then we can take this result and plug it into G. So we'll continue this here. So then we're going to say G of 1. We basically took that answer and plugged it into G. And then G is x plus 1. So that's going to be x plus 1. So then that result is 2. Okay, let's do one more. Again, this is evaluating a composite function. So then C, for part C, f of negative 1. So we have f of negative 1. Okay. So then this means f of -1. Okay. Oof. What time is it? F, I think, is x squared. So this is f of -1 squared cubed, which is ultimately just -1. So then it goes back to f of -1, and we just saw that that result is -1. So we got 8, 2, and -1. You see the 8 there? And then 2 and -1. What time is it? Okay. So let f of x be this, g of x be this, and we're asked to find each of the following. Yeah, let me get myself some space. Check something. Let me check Zoom really quickly. Let's go like this. Can you guys? So someone said I'm muted. Can you hear me? Can you guys hear me? Okay. Cause hello.
No, I can hear
You can hear. You can hear me.
you. Yeah, I can hear you.
Okay. And then let me check and see if we got. Let me get the student. Let's see. Oh, he must have just got booted out because he was here. Yes, no worries. Okay. Yeah, I got him already. That's fine. Okay, let's keep going. Start the broadcast. Okay. So f is this, g is this, and then we have these composite functions. Okay, yeah, let's give ourselves some space. Okay. So then for f of x, we have 2x plus 1. For g of x, we have x squared minus 3. For a, f compose g of x. For part B, let me see, it says find each composite function. Okay. We got g compose f of x, and then part C, f of x. Okay. So then for part A again, f of g of x, what this means is the second function inside the first function. So this means f of, and I like to do g in green. All right. So then what's our g of x? So this means f of, our g of x is x squared minus 3. Okay. Let me check really quickly. Squared minus 3, okay. All right. So then what this means is that basically we write f like normal, but we replace each x with the green thing. So then this is going to be 2x plus 1. So first I replace my x with a blank set of parentheses. Then I'm going to put the green thing into the blank parentheses, x squared minus 3. Then I'm going to expand and simplify. Okay, so we can distribute here. And keep in mind, all the stuff that I'm writing, you'll receive a copy of it. You can find it, access it on our Blackboard page. I think link number 3 is going to say daily lecture notes, box link. The link that says box link, you want to click on that, and it's going to open up the box. It's going to open up box. And then within that folder, you're going to see a folder that says notes, and you'll find it in there. The one, what we did today, basically what we've been doing every day. All right. So let's keep going. If we distribute, we'll get 2x squared. That's going to be what? Minus 6 plus 1 ultimately is going to be minus 5. Okay. All right. B. G composed F of x.
Excuse me, Professor, I have a question.
Yes.
So at the end of problem A, do you just not do anything with the x on the parentheses at
You
the
talking?
end?
Oh, this guy here.
Yeah.
Yeah, no, you don't do anything with this. Like, basically, it's like it just this. Let me see. This notation, all it means is this guy.
Okay.
Yeah, like because the common mistake that I know students have done this in the past, they try to distribute this x. This is not multiplication. This is like function notation, right? So it's like when you say f of x, you wouldn't distribute the x into the function. It just means the function f evaluated at the value of x. This is function notation, and it means this, all right, by definition,
Okay.
right? Yeah.
All right. Thank you.
My pleasure. That's a good question. Let's see, right here, right? So we have g of f of x. Okay, what does this mean? This means g of f of x, right? The second function inside the first function. Second function inside the first function. Okay. So then this means g of, now our f of x is 2x plus 1. So then what we're doing is we're writing the function g like normal, but we're replacing the x's from g with the fuchsia thing. I think that's fuchsia. Let me see something. Hey Siri, what color does fuchsia look like?
Fuchsia is a vivid purplish red color,
Yeah.
named after the color of the flower of the fuchsia plant, which was named by a French botanist, Charles Plumier, after the 16th century German botanist Leonhard Fuchs. Want to hear more?
No, I'm good, thanks. No, thank you. That was interesting though. His name was Charles. I was like, come on. Yeah, so yeah, it does look like this. Okay, let's keep going. I see we're almost out of time. I would like to get to, you might have to check out my pre-recorded lecture for the domain ones. It might come out when we work on the homework on Wednesday. But let's try to keep going. So then g is x squared minus 3. So then this equals x squared minus 3. But we replace each x with the fuchsia thing, which is 2x plus 1, right? At this point, we expand, simplify, and combine like terms. So if you FOIL, it's going to be 4x squared plus 4x plus 1 minus 3. 1 minus 3 is what? -2. I don't feel like writing all that, so I'm just going to say -2. Okay. Maybe we might talk about domain of this one, but these are not interesting ones for domain. Okay, that was B. Let's do C, f of x. C, f of x. I wonder if any of you guys like content creators? Do you do have your own YouTube channel? I think that's, I mean, obviously in this day and age, that's a great talent to have, because I need to create a logo, an intro, and an outro. If somebody knows how to do that, that would be awesome, right? I always think about I have all these ideas, right? I want to make all this stuff. I think I've mentioned this before, but use a 3D printer, and I have all these ideas for things that I want to make, so many different things. But it's all kind of lumped together. But it's neat, and I just have a lot of different creative things that I want to do. But anyway, let's keep going. F is 2x plus 1, right? So this means f of, I guess we can be consistent. F of x, the second function inside the first function, right? F of x. So this is going to be f of 2x plus 1. Okay. So then we're going to just write f like normal, but replace each x with the fuchsia thing. So it's going to be 2x plus 1, but then we plug in the 2x plus 1. Okay, so then when we expand, we're going to be distributing here. We're going to get 4x plus 2 plus 1, 4x plus 3. Let's see, how do we do? Let's see, we got 2x squared minus 5, 4x squared plus 4x minus 2, and 4x plus 3. 2x squared minus 5, I think that sounds familiar, right? 4x squared plus 4x minus 2, and then 4x plus 3. Okay. Ooh, we really do need to do this. Okay. We'll make part A the last part for today. Okay. So we're given that. So we have that f of x equals x plus 1, g of x equals 1 divided by x. Okay. For part A, we're asked to find f composed g of x and this domain, right? So the main point of this is I want you to see at least one demo on domain. Okay, so what does this mean? This means the second function inside the first function. So f of g of x. Okay. So then that's going to be f of 1 over x. Okay. So then f is x plus 1. Okay. I think we can probably leave it like that. Let me think. Yeah, I think I'm gonna just leave it like this. I mean, we could get like a common denominator, but I'm gonna leave it like this for now. Okay. So then for the domain now, the 3-step process for the domain. So I'll do this in purple because this is just like how I like to do it. So I'm gonna say domain of a composite. I'm a shorthanded. All right. First, we want to find the domain of the inside function. Secondly, we want to find the domain of the simplified function. And then third, we want to take their intersection. Basically, we want to see where do they overlap, right? So so for part A, if we're doing f of g of x, thank you, I know, thank you. So the first part for the inside function, that's going to be the domain of g, 1 over x, right? So I think we said for rational functions, the domain in general is all reals except any x that makes the denominator 0. So for the domain of g is going to be everything except 0. So we're going to say x is not equal to 0. Okay, so that's for the inside function. And then secondly, we want to consider the simplified. The simplified being the part that we have in the box near the top of the screen. The only restriction is, again, we cannot divide by 0. So it just happens to be the same. Again, that's going to be the domain of the simplified. I'm gonna just shorthand it. And it just happens to be the same in this case, all right? So then the third part, let's just continue. So then next the final step is to take the intersection, take their intersection. Okay. So, I mean, basically these two sets are the same. So a set intersect itself, I'm just gonna use some shorthand. I'm gonna say x not equal to 0 intersection x not equal to 0 basically is gonna be itself, right? And to write that in interval notation, we want everything except 0. So if we think about like the number line, say here's 0, again, we want everything except 0. So we want everything to the left of 0. We want everything to the right of 0, but we don't want 0, so we put parentheses. So then that's the graph. And to capture this in interval notation, the far left is going to be negative infinity up until 0. And then we're jumping over 0. We're going to go from 0 to infinity. Infinity always gets a parentheses. Again, because we do not want 0, we use a parentheses on 0 because the parentheses in this context means we get really, really close. We get infinitesimally close to 0, but we don't include it. And then the solution is going to be basically, we combine it with a union to say that you can choose any number from these two sets. The U is like a union. It just means the first set in conjunction with the second set. Okay. And then just to confirm, so you see the 1 over x plus 1, and then negative infinity to 0, union 0 to infinity. Right. So that's gonna take some practice. And just do the best you can with it. I mean, it's not dire. Like this isn't life or death. Just do the best you can with it. Just do the best you can with that. Okay. All right. Are there any questions that, with the time that we have? Let me go ahead and send a copy of this to Box so that you guys can access it. This is the fall of 22, College Algebra 1, into the notes, update it daily, and right into there. All that looks good. It's in the box. So when this bar finishes loading, you'll get a copy of everything that you saw me writing today. So on Wednesday, we'll go ahead and go through as many homework assignments associated with this. It is a good idea to come with questions, but if you're figuring it out, it's all good, right? If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Peace.